And so here we're going to jump around a little bit in the textbook, and we're going to go ahead to chapter 9. The reason why we want to go into chapter 9 is because it's kind of somewhat of a review of what we did in geometry last year, but we're also going to extend upon that and show you guys something new and how we use trigonometry in a more algebraic sense. Okay, so trigonometry, if you remember from geometry, is the study of right triangles and how we use right triangles to solve everyday problems. Okay, so here we have in this figure on the right, it's just something very important. It's a typical standard right triangle. Now there's something in here that you're probably not familiar with, and that's this symbol. Now this symbol is what we call theta, and it's just a Greek letter in the alphabet. So that's going to be the variable that we're going to be working with. So it's just going to count as x, or any other variable we typically use. It's a Greek letter. Okay. Now that Greek letter theta will be used often, and that's usually going to be represented by the angle measurement in the triangle. Okay. Now, if that is our theta, a couple things I want to kind of reference here is the side that's opposite of theta is this leg of the right triangle here. This is the opposite leg. Okay, the adjacent side will be the side that is next to the theta. And then we know the hypotenuse is always going to be opposite of the right angle. Okay, so that information you're going to have to kind of remember, kind of know, because that'll be definitely helpful for when we're doing some of the trigonometry for these triangles. Now, the three main ones that we've learned in the past were sine, cosine, and tangent. Okay, so those were all the same from when you learned them in the previous year, and those are the only three that you use. Now, what we're going to extend upon with that are these three here, and I'm going to write this in green. We have what's called the secant, the cosecant, and the cotangent. Now, those are other three identities, or trig functions that we can use other than the original three, right? These three up here are the original ones. These here are what we consider the new ones. Now there's an abbreviation for each of these. Secant is just SEC, cosecant is CSC, and cotangent is COT. So whenever we talk about these, we're talking about these functions here. Okay, so all in all, that's going to give us 6 different ones to work with or have. Okay, we have sine, cosine, tangent. That's 1, 2, and 3. And then we have secant, cosecant, and cotangent. Those are the 6 ones. Okay. Now, if you haven't done so already, please copy this entire reference guide here in your textbook, and we're going to talk about that a little bit. What you kind of need to know, and what you should know in reality from last year, is that sine is opposite over hypotenuse. So that's going to be, if our theta is here, it's going to be the opposite side divided by our hypotenuse. That's the ratio you want to use. Cosine is the adjacent side over the hypotenuse, and tangent is the opposite over the adjacent. Now these three kind of were drilled into you last year when you took geometry, so those are ones that you've already come to know and love. Now, cosecant, these three here, these are the given definitions, and I will get familiar with those. Okay, cosecant is hypotenuse divided by opposite. Secant is hypotenuse divided by adjacent, and cotangent is adjacent over opposite. Now, what do you guys notice between the sine and the cosecant, the cosine and the secant, and the tangent and the cotangent? Is there anything you guys notice in terms of the ratios? Now, if you said that they're flipped or they're just reciprocals, then that is the case. That is very true. Okay, and that's kind of what's telling us here. All right, what it's telling us is that secant, cosecant, and sine are reciprocals. Secant and cosine are reciprocals. Cotangent and tangent are reciprocals. So finding the other three, once we know the original, sine, cosine, tangent, aren't necessarily that difficult because it's just taking the reciprocal of sine, cosine, and tangent. So those are the other three that we're going to be working with quite a bit in this section, okay? So this is kind of an introduction, okay? I know it's kind of, a little bit difficult because we haven't done any examples just yet, but hopefully some of the examples can help you guys out once we're working on them. All right, so here we go. So we want to evaluate the 6 trigonometric functions of angle theta. So they want us to find all 6. All right, now the first thing here is we don't have the third side for number 1. Okay, so can anyone tell me how do you usually find the third side of a right triangle? That is using Pythagorean's theorem. So we're going to set it up. 3 squared plus 4 squared equals the hypotenuse squared. So we don't know what that is right now, so we're going to go c squared. So that's going to give me 9 plus 16 equals c squared. 25 is equal to c squared. So therefore 5 is equal to c. All right, so I know that this measurement here, the length of that segment is 5. Now for number 1, they want us to find the trig function values of the angle theta. So let's start with sine. What is the sine of the angle theta? So if you remember, or you should have it in your notes, so sine of theta is opposite over the hypotenuse. So that's going to give me 3 over 5. Cosine theta is going to be the adjacent over the hypotenuse. So that's going to give me 4 over 5. Tangent is opposite over adjacent. So in that triangle, opposite is 3, adjacent is 4, so we get 3/4. Now for the other 3, you just have to know the relationship, right? So let's start with cosecant. Cosecant is the reciprocal of sine. So what is sine? 3 over 5, cosecant is going to be 5 over 3. Secant is the reciprocal of cosine, so that's going to be 5 over 4. And cotangent is the reciprocal of tangent, okay, so that's going to be 4 over 3. And there you go. Those are the 6 trig function values of the first one we did, okay? So not too much work. Once you have all 3 ratios, obviously, we had to use the Pythagorean theorem first up here. So once we did Pythagorean theorem to find the third side, then we were able to use the 3 ratios to find the initial 3 here. And once we have the initial 3, then it was just a matter of taking the reciprocal of those. Again, what I would do is I would kind of practice and understand what are reciprocals, so sine and cosecant. Cosine and secant are reciprocals, and then the tangents are reciprocals of each other. That's the easier one to remember, okay? All right, so let's go on to number 2. All right, so I'm going to clear this out. You could just rewind the video if you need the work. All right, we're going to go ahead and work on number 2 now. All right, so number 2, again, we have to start with Pythagorean theorem. So 17 squared is the hypotenuse, and that's going to be equal to 15 squared. And we're going to go with b squared because we don't know what the other side there is. So that's going to give me 289 is equal to 225 plus b squared. If I subtract, I get 64 equals b squared. So then 8 is equal to b. All right, so we're going to have a third side of 8 there. All right, and then we want to find our ratios. So we'll start with sine. Sine is opposite over hypotenuse. So again, we have to pay attention for where this angle is. So the angle opposite is going to be, or the side opposite is going to be 15. So that's 15 over the hypotenuse, which is 17. Cosine theta is the adjacent side, so that's 8 over 17. Tangent theta is going to be opposite 15 over adjacent 8. Okay, now we have those 3. Now it's a matter of getting the reciprocal functions here. So what is the cosecant theta? That's the reciprocal for sine, so that's 17 over 15. The secant theta is the reciprocal of cosine, so that's 17 over 8. And then the cotangent theta is the reciprocal for tangent, so 8 over 15. Okay, there you go. You have all three there. Okay, if you have any questions, again, feel free to email me or ask me to Google Classroom. But again, just similar to the first problem we did, find a third side first, then set up your ratios to identify what they're equal to. Okay, let's do the last one here with number 3. Again, I'm going to go ahead and erase it. So we can go ahead and start. Okay, so the third side here, again, we're missing a leg. Now, we're going to have 5 squared plus b squared is equal to 5 radical 2 squared. Okay, so that's 25 plus b squared is equal to, now here when you square an irrational expression like this, you're going to square the coefficient, so that's 25, and then radical 2 to the second power is just 2, so we get 25 times 2. So that's going to give me 25 plus b squared is equal to 50, b squared is equal to 25, b is equal to 5. Okay, so that third side there is 5. Okay, so now we need to find our trig ratios here, and we're going to start with sine. So sine is going to be 5 opposite over 5 radical 2, but we need to simplify this as much as we can, okay? So the first thing I want to do is I notice that there is a 5 in the numerator and in the denominator, so I'm going to simplify that. And that's going to leave me with 1 over radical 2. How do I rationalize the denominator here? I take this 1 over radical 2 and I multiply it by radical 2 over radical 2. That's going to give me radical 2 in the numerator, and in my denominator I'm just going to get a positive 2. So my sine theta is radical 2 over 2. Okay, let's look at cosine. So cosine theta is going to be equal to 5 over 5 radical 2. So it looks like it's the same ratio. So we already know that that's going to simplify to radical 2 over 2. So here's a case where sine and cosine are the exact same function value. Let's look at tangent. All right, tangent is going to be 5 over 5. Now 5 over 5, that's simple. That's just going to be equal to 1. Okay, so tangent theta is equal to 1. Now what we need to do is we need to find the reciprocal ones. So we're going to start with sine. Okay, so sine, that's going to give me cosecant as the reciprocal. We're going to look at this reciprocal. That's going to be 2 over radical 2. Okay, so we have to multiply by radical 2 on both the numerator and denominator. That gives me 2 radical 2 over 2. And then algebraically, what simplifies there is that the 2's cancel out. So I get radical 2. If cosine was the same thing, then the reciprocal is also going to give me radical 2. Okay? And then cotangent theta, the reciprocal of 1, what's the reciprocal of 1? 1. All right, so there you go. There's your cotangent. Here's your secant, and then your cosecant is here. Okay, so those are the 6 trig function values of the last one. Now, what you have to be comfortable with, okay, as we get into some of the more complex problems, is you're going to have to learn how to deal with radicals very often. And again, you're going to have to apply those rules. Now, we've done this a bunch of times earlier in the year, and this is where it comes back, right? It comes back again here in triangles. So you just have to be proficient at simplifying expressions dealing with radicals. Okay. Again, this was the harder of the 3, but again, as long as you follow any of the rules that you've learned in the past, there shouldn't be too much of an issue when you're trying to solve it. Okay, let's look at number 4 here. Now, here in number 4, they did not draw us a triangle. What they want us to kind of understand is what the cosine ratio represents here. Okay, so it says in a right triangle. So we don't know what the triangle looks like, but we can draw any right triangle. So I'm going to go ahead and do that. Okay, so here's my right triangle. Theta is an acute angle, so pick one of the two acute angles and label it theta. Now it does not matter which one you pick. I'm gonna go ahead and pick this one, but it really does not matter, okay? And I'll show you why it won't matter after we do this first part. Okay, it's telling me that the cosine of theta is 7/10. I know cosine is equal to the adjacent over the hypotenuse. Okay, so which side is 7 and which side would be 10? So 7 is adjacent and the hypotenuse is 10. Now they want me to find what is the sine of theta. So we are looking for the sine of theta. I know by definition the sine of theta is opposite over hypotenuse. So I know the hypotenuse is 10. What I don't know is the numerator for the opposite side. So I need to figure out what this length here is. We're going to label that A. So A squared plus 7 squared equals 10 squared. A squared plus 49 equals 100. A squared equals 51. A is equal to radical 51. Okay, so radical 51 is going to be the value of A. So that's also going to be the numerator of my sine value. So sine of theta is just going to be equal to radical 51 over 10. Okay, so that's your function value. So here's a question where they want you to understand the ratio, what it means in terms of that, in terms of the triangle. And use that information to find the value of another one. Okay, so here's one. They don't give you an image, you just have to generate your image. Now what I wanted to kind of show you here is what happened if we pick the top angle as theta, right? So let's say that this is my theta. Well, that would just mean that the adjacent would be 7, the hypotenuse would be 10, and you still need to use Pythagorean theorem, and you're still going to get radical 51. So nothing changes, okay? It's still the same thing. You decide exactly what, which kind of one you want to draw. It's all up to you. It's personal preference, but the ratio sides are still going to come out the same. So nothing much to really think about there. Just drawing it correctly and applying the correct ratio is the key there. Okay, so we're going to look at special angles here. These are going to go into your notebook. The special angles that we always kind of work with are the 30, the 45, and the 60. Now these three angles come from these two cases here, right? So this one is an isosceles right triangle. Okay, and we usually call that the 45, 45, 90 right triangle. And this one is the 30, not 36, 30, 60, 90 right triangle. Right, so these two are very, very important. And I also want you to look at the ratios of the sides. So in the isosceles right triangle, the ratio of the sides is 1 to 1 to radical 2. And the ratio of a 30, 60, 90 is 1 to radical 3 to 2. Now these ratios are very, very important because they're actually used in a lot of applications of trigonometry because these are the two most prevalent right triangles. But those are ratios that are going to come around a lot. And if you kind of notice, 1 radical 3, 2, 1, 1 radical 2, in this entire chart, you see a lot of those values come up. Okay, you see a lot of 1s, you see a lot of radical 2s, you see a lot of radical 3s, right? So they're constantly coming up in some of the problems we're going to be working with. Okay, so now what this chart nicely did for us is if we need to figure out what the, let's say if I told you to find the tangent of 45, all you have to do with this chart is you go to tangent, you go to 45, and that value is equal to 1. Okay, so this chart lays it out nicely for us. I would put this chart in a good place along with the definitions of the 6 trigonometric functions, because you're going to have to reference these quite a bit throughout the chapter. Okay, so just have those ready in your notebook because we'll be able to use those, for our benefit. Okay, so here we go. Find the value of x for the right triangle shown. Okay. All right, so we have this right triangle. Okay. So if that's a 30-degree angle, I know this is going to be a 60-degree angle. Okay. So we have that much information. The only problem is we are missing two sides here, right? We don't know what this side is and we don't know what this side is, but they want us to solve for the value of x. Okay, so just with the information that they gave us, so that's the 30-degree angle, that's going to be the 8 and the x. Just with that information, what trig ratio can we kind of make up already? So in terms of the angle of 30, I have the adjacent side and I have my hypotenuse side. So what trig ratio does that give us? That's going to be cosine. So the cosine of this 30-degree angle is going to be equal to the adjacent side, which is x, over 8. Now, based on the chart on the previous screen, which you should now have in your notebooks, what is the cosine of 30 equal to? If you said radical 3 over 2, you are correct. Okay, cosine of 30 is equal to radical 3 over 2. Now, why would I do that here? Well, what did I just create? I just created a proportion. Okay, so now we can solve that proportion with no problem and figure out what x is. Okay, so I cross multiply. I'm going to get 8 radical 3 is equal to 2x. I need to solve for x, so I'm going to divide both sides by 2. That's going to give me 8 radical 3 over 2 is equal to x. If I simplify here, I can simplify this fraction. The 8 simplifies to a 4 and the 2 goes away, so then that's going to give me 4 radical 3. Okay, so 4 radical 3 is what I get for my value of x. That is the length of the x, or the adjacent side of the triangle. Okay, so knowing what cosine of 30 was equal to actually really helped me very much in terms of solving this problem. Okay, so now let's solve some more triangles. Okay, so a little bit of more information. So number 5, we're going to use this triangle on the right hand side. Number 6 as well, so I'll be erasing and coming back. Just pause the video wherever you need to. All right, so number 5, we have the information that angle B is 45, okay, and the length of C, which is here, is 5, okay? So they want us to solve the triangle. Now, what it means to solve the triangle is they want us to find every single piece of the triangle possible. So all the angles, all the sides, okay? So I know that this is a 45. This is also a 45. So right there, I already know, and I can tell them that angle A, which is capital, is equal to 45 degrees, okay? They gave us angle C, so we don't need to solve that. And we have angle B, so all the angles are done. Now, the only thing that's not done is we have to find A and we have to find B, okay? So, let's say I am using what they gave us up here. So we're gonna use angle B, okay? So, the sine of the angle B, which is 45, is equal to the opposite, little b, over the hypotenuse, which is 5. What is the sine of 45? Well, the sine of 45, based on the chart, is radical 2 over 2. Okay, so now I can solve for b by cross multiplying. So that's going to give me 5 radical 2 equals 2b. b is going to be equal to 5 radical 2 over 2. That can't be simplified, so there's your b value. Okay, now we want to do the same thing to solve for a. But this time, instead of using sine, we're going to use cosine of that 45. Okay, that's also going to give me radical 2 over 2. So it looks like this one is just going to be a case where it's an isosceles right triangle. We're going to get 5 radical 2 equals 2b. Sorry, I put b, this should be a. So a over 5, a over 5, 2a, 5 radical 2 over 2 equals a. Okay, so we have big B, big A, and we know C was a right angle here, so that's 3 angles. Then we have little c, we have little b, and little a. So we have the 3 sides and the 3 angles. Okay, Now let's go ahead and move on to the next one, and we're going to look at the second right triangle here, but it's going to have different measurements. Okay, so here they're telling us that big A is 32 and little b is 10. We want to find big B, little a, little c. Now big B is to be the easiest one here, so the measure, we're going to get rid of this so you don't get confused. The measure of B is, well, if this is 90 and this is 32, right, then what is the sum of those two? 90 and 32 is 122. So B is going to be 180 minus 122. 180 minus 122 is 58. So B is 58 degrees. Okay, so now all we want to look for is we want to look for the side of A and the side of C. Now, notice that in our chart, there's nothing talking about 32 and there's nothing talking about 58. So this is where we go back to geometry a little bit, and we have to kind of figure out, okay, what can I do instead that's going to help me solve this? So what you actually have to do is go back and use a little bit of trigonometry with your calculators. Okay, so let's say I want to solve for A first. Okay, so if I want to solve for A first and I have B, what ratio can I use? Well, I can use that the tangent of 32 is equal to A over 10. Okay, then I'm going to solve. So again, this is just like a proportion. I'm going to cross multiply. So A is equal to 10 times the tangent of 32. Now, to figure out what this is equal to, you actually have to use a calculator. Okay, and I'm going to try to do that here. But you also have to make sure of one very, very important thing. Your calculator needs to be in degree mode. If you have a basic scientific calculator, it's going to be in that degree mode already. If you have a graphing calculator, you have to make sure you change it into degree mode. Okay, so it has to be in degree mode when you're working on this, but most basic scientific calculators, okay, they will do that for you with no issue. All right, so let's see if I can get a calculator here open for us. Let's see. Here we go. Here's a scientific calculator. Okay, so we need to figure out what 10 times tangent of 32 is. So let's do 10 times tangent of 32. Now notice my calculator here says degree. Okay, so you just want to make sure you are in degrees. So here I get A is about 6.24. Okay, so 6.24 is going to be the length for A. Okay, all right, so now we go back to our image here. Now I found A, now let's do the second part in finding B. I want to find B. I mean, sorry, not B, C. My mistakes. Okay, I have B. I want to find C. Okay, to find C, if I'm using the 10 and the 32, what ratio do I have? Well, I have the angle, I have the adjacent side, and I want to find the hypotenuse. So that's going to be the cosine of 32 is equal to 10 over C. Again, it's a proportion, so we're going to go ahead and solve that. Cross multiply, 10 is equal to cosine of 32 times C. But I want to solve for C alone, so it's going to be 10 divided by the cosine of 32 is equal to C. Now again, we take our calculators and we see what that gives us. So let's clear this out. It's going to be 10 divided by the cosine of 32. So that is approximately 11.79. Okay, so That is the length of our C value. It's an approximation. Oh, okay, so again, approximation, but just using some trigonometry that we've learned in the past. Okay, now if it is not one of the major angles, if it's not 30, 45, and 60, then we can't use the chart, so we're going to have to go ahead and use a calculator. Again, I just showed you how to use the calculator if you need to use it. Just please, 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 if you're using a calculator, make sure it's in degree mode. Okay, if you have any questions about that calculator process, feel free to reach out to me. I can definitely help you out, okay? All right, and then the last one is a word problem. Like every trigonometry chapter or anyone who really teaches it does a lot of word problems for these because it is important to understand that it has very high applications in the real world, right? So here's a parasailing problem. Now, please do not make fun of my drawings. I'm not the best artist. I try to make them as fun and friendly as possible, so you can have a little laugh, but I'm not the best drawer in the world, so please forgive me for the drawings. All right, so a parasailer is attached to a boat with a rope that's 300 feet long. The angle of elevation from the boat to the parasailer is 48 degrees. Estimate the parasailer's height above the boat. All right, so now before we get into the whole situation, I want you guys to understand that there's two specific type of angles that we like to work with. One of them is the angle of elevation. Okay, now when you talk about elevation, we're talking about things that go in an upward motion. So let's say you are here, okay, and you are looking this way. This is your point of view, okay? Your point of view for an angle of elevation will be traveling in an upward direction. So as you are looking horizontally and you look upwards, this angle that you create is what we call the angle of elevation. Now there is another one. The other one is what we call the angle of depression. Now it just means to push down, okay, or to go downward. So the angle of depression, again, with your horizontal line of sight, is going in a downward direction. So your angle this way, if you were looking horizontally and then look downward, that would be considered an angle of depression. So for this problem, they're telling us that the angle of elevation from the boat to the parasailer is 48 degrees. So that means it's going to be an upward angle, and that's the one we're going to want to work with, okay? So let's draw the situation and kind of see what's happening. Okay, so I have a boat. Here's my boat. And there's a parasailer that is attached to the boat. So here's the rope. They told us that this rope is 300 feet long, and there's a parasailer on this boat. So here's the person attached, and I don't know if I can draw the parachute. There it is. All right, so there's a parasailer attached to this boat that's 300 feet long. The angle of elevation from the boat to the parasailer is 48 degrees. Okay, so remember, angle of elevation is a horizontal position, and you're looking upward, right? So this angle here is 48 degrees. Okay, this angle here is 48 degrees. I tried to draw an arrow there, but that's not working out too well. Let me see if I can fix that. So, oops. Okay, so this angle here is 48 degrees from here to here. It says estimate the parasailer's height above the boat. So what it's looking for is height. Height is always measured by a perpendicular line. So here's the height of the person. So we're just looking for that measurement there. Okay, so we have to figure out which trig ratio can I use if I have this situation. Okay, so I have this angle. I have this side that I need to look for. Now that's the opposite side. And I have my hypotenuse because that's opposite of the right triangle, of the right angle. So if I need to find opposite and I have the hypotenuse, I'm going to be using the sine. So sine of 48 is equal to h over 300. All right, again, we want to solve this equation, so here's our proportion. So h is equal to 300 times the sine of 48. So what is 300 times the sine of 48? Okay, so now, again, we need to use a calculator. So we're going to clear this out. So we have 300 times the sine of 48. And we're going to close the parentheses. And that's going to give me a height of 222.94 feet. So that's how high this parasailer is. That's pretty high off above the water. All right, but that's how high the parasailer is. That's what the question they want us to ask. Again, just a quick setup and then use trigonometry. All right, if you're wondering what calculator I'm using, I'm actually using the Desmos Scientific Calculator. It's an app. All right, so if you go on the Play Store or in Google Play, you should be able to find that with no problem. Okay. Besides that, that's pretty much it. Again, this is a nice little introduction to relearning trigonometry. A lot of it is going to be just review based. So, you know, we're going to stretch out the homework a little bit just so you guys have a little, if you have questions, you can ask them. But it is very important that you start to understand that sine, cosine, and tangent have reciprocals. And those reciprocals are cosecant, secant, and cotangent. That's something that we're going to need to be aware of as we move on throughout the chapter. Okay, so again, if you have any questions, please reach out to me. Don't be afraid. We are now on week 6 of remote learning. There's not that many weeks of school left, so let's try to make the best of it. Let's try to close out on a strong note. Otherwise, thank you for watching. Hopefully this taught you well.